Hello friends, welcome back to a new video of I square. We were dealing with the chapter pair of linear equations in two variables, and in today's class we are going to check some pair of linear equations whether the solutions of the pair of linear equations are consistent or not. Let's move on to the questions. And the first question is x plus y equal to 5 and 2x plus 2y equals to 10. We want to check whether the solution of this pair of equations is consistent or inconsistent. And if we obtain that it is consistent, we have to find the solution graphically. So first of all, we have the question here. We know that the general form of a pair of linear equation in two variable is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Comparing the general form with the question given, we can easily find the ratios a1 by a2, b1 by b2 and c1 by c2, and hence analyzing those ratios we can find whether the solution is consistent or inconsistent. First of all, let's find a1 by a2. And from these two equations we can clearly find that a1 is the coefficient of x, and here the coefficient of x is nothing but 1, by a2 here the coefficient of x is 2, therefore the ratio a1 by a2 is nothing but 1 by 2. Now let's go for b1 by b2. And b1 by b2, for b1 by b2 we have the coefficient of y as 1, and here the coefficient of y as 2, and the ratio is 1 by 2 again. Now here this is c1 and c2, here we have this is minus c1 and minus c2. If here x plus y minus 5 equals to 0 and 2x plus 2y minus 10 equals to 0 is just another form of these two equations. So rather than considering these equations, we can consider these equations too for finding c1 by c2. So here c1 is nothing but minus 5 and c2 is again minus 10. So the ratio becomes 1 by 2 again. From all these ratios, that is a1 by a2, b1 by b2 and c1 by c2, it is clear that all of these are equal to a fixed number, that is 1 by 2, which means it satisfies the second condition, a1 by a2 equals to b1 by b2 equals to c1 by c2, which means the lines are coincident. Therefore, it has a solution. It has infinitely many solutions. So the solution is consistent. More specifically, it is dependently consistent. Now, we are asked to find the solution graphically if the solution is consistent. Now, we found that the solution is consistent, so we have to move on for the graphical solution. For the graphical solution, we need the solution table for both the equations, and hence we will draw the graphs. First, let's consider the equation x plus y equals to 5. For the solution table, we want to put some random values for x and hence find the value of y. First of all, let's put x is equal to 0. If x is equal to 0, this equation will become like this: 0 plus y equals to 5 and y is equal to 5. So when x is equal to 0, we have y is equal to 5. Now let's put x is equal to 5. Then this equation will become like this: 5 plus y equals to 5, and which means y is equal to 5 minus 5, which is 0. So when x is equal to 5, we have y is equals to 0. So we got 2 points in this equation, that is 0, 5 and 5, 0. So let's draw these 2 points in the graph. We know that this is 0, this is 5, so this is our point 0, 5. And again we have 5, 0. This is 5 and this is 0, so we have this point as 5, 0. So the line joining 0, 5 and 5, 0 is the required solution of the first equation. So this is the required solution of our first equation. Now we have to go for the second equation, that is 2x plus 2y equals to 10. we can go for the solution table, and for that we want to put random values for x and find the values of y. For example, let's put x is equal to 1. When x is equal to 1, we have 2 plus 2y equals to 10. That is 2y becomes 10 minus 2, which is 8, and y becomes 8 by 2, that is 4. So when x is equal to 1, we have y is equal to 4. Now we will go for another solution. So let's put x is equal to 2. We can put x is equal to 2 in this equation. So we have 2 into 2 plus 2y equals to 10. So 2 into 2 is nothing but 4. 4 plus 2y equals to 10. Therefore 2y equals to 10 minus 4, which is 6, and y is equal to 6 by 2, that is 3. So when x is equal to 2, we have y is equal to 3. So we got another 2 points for the second equations, that is 1, 4 and 2, 3 is a solution for this equation. Now let's plot those 2 points in the graph, that is 1, 4. This is 1 in x-axis and 4 in y-axis. So we have this as 1, 4. This point. Again we have 2, 3. This is 2 in x-axis and this is 3 in y-axis. So we have this point. So the line joining these 2 points will be again the solution of our second equation, and we can find that these 2 lines are coincident. That the same conclusion is formed when we checked the condition algebraically. That is, we got that a1 by a2 equals to b1 by b2 equals to c1 by c2, and we found that the solution is consistent and they are coincident. So all the points in this line is the solution set for this particular pair of linear equations in 2 variables. Now we can solve another problem. Now the next question is x minus y equals to 8 and 3x minus 3y equals to 16. We have to check whether this pair of linear equation have a consistent solution or an inconsistent solution. We will check for that. For that we want a1, a2, b1, b2 and c1, c2, and we want to find the ratios a1 by a2, b1 by b2 and c1 by c2. From here we can find a1 by a2, which means the ratio of coefficient of x, that is here the coefficient of x is 1 by here the coefficient of x is 3. So the ratio a1 by a2 is nothing but 1 by 3. Now we will go for b1 by b2, and now b1 by b2 is the ratio of coefficients of y, that is here the coefficient of y is minus 1 and here the coefficient of y is minus 3, and the ratio is nothing but 1 by 3 again. Okay, now we want to find the ratio of c1 by c2. Either we can take the ratio from the RHS, or we can take both the C1 and C2 to LHS and find the ratio. Both are same. Here we can find the ratio from RHS itself, that is 8 by 16, that is 1 by 2. And from here we can conclude that a1 by a2 is equals to b1 by b2. Both are 1 by 3, but these two ratios are not equal to 1 by 2. So that is, which is not equal to our c1 by c2. And this condition is the third condition here. a1 by a2 equals to b1 by b2 not equals to c1 by c2, which means the lines are parallel, which means both the lines will never intersect, which means there is no solution for this particular pair of linear equations. If there is no solution, we can say that this pair of linear equation has inconsistent solution. That is no solution. Now another question we have to discuss is 2x plus y minus 6 equals to 0 and 4x minus 2y minus 4 equals to 0. We have to check for the consistency of this pair of linear equations. For that we have to find the ratios a1 by a2, b1 by b2 and c1 by c2 and check whether which of these conditions are satisfied. First we have to find a1 by a2, that is the ratio of coefficients of x, that is here it is 2 by 4 because here the coefficient of x is 2 and here the coefficient of x is 4, and in simplified form the ratio will become 1 by 2. Now we will go for b1 by b2, that is the ratio of coefficient of y. Here the coefficient of y is nothing but 1 and here it is minus 2, and in simplified form we have minus 1 by 2 as the ratio. And from these two ratios we can conclude that a1 by a2 is not equal to b1 by b2, which is our first condition. a1 by a2 equals to not equals to b1 by b2, which means in the graphical solution the lines will intersect at a single point, and such a solution is always consistent. Since we found that the solution is consistent, we have to solve it graphically. For that, we want the solution set for both of these equations, and first of all we can find the solution set of the first equation, that is 2x plus y minus 6 equals to 0. In order to find the solution set, we have to put random values for x and hence find the values of y. First of all, we can put x is equals to 0. From this first equation, we can find the value of x, that is 2x is equal to 6 minus y, and x is equal to, we can find the value of y, that is y is equal to 6 minus 2x. Now we want to put the value of x as 0 here, that is 6 minus 2 into 0, that is 6. So when x is equal to 0, we have y equals to 6. Now we will go for another point for x, that is, let's put x is equal to 3. We know that y is equal to 6 minus 2x from this equation, that is y equals to 6 minus 2 into 3. So 2 into 3 is again 6, that is 6 minus 6 is 0 here. So when x is equal to 3, we have y is equal to 0. So we got 2 points for this solution, for the solution of this equation, that is 0, 6 and 3, 0. Let's plot these points in the graph. We have 0, we want to plot 0, 6. So we know that this is 5 and this is 6. So we have 0, 6 as here. So this is our point 0, 6. Now we want to plot 3, 0. This is 3 and this is 0. So this is our point 3, 0. So the solution for this particular equation is the line joining these 2 points, that is this point is the point of this line is the solution for this particular equation. Now we will find the solution set for the second equation, that is 4x minus 2y equal minus 4 equals to minus 2y minus 4 equals to 0. First of all, we can find the solution table and put the value of x as 0. We can find the value of y from this equation, that is minus 2y is nothing but 4 minus 4x, and y is 4 minus 4x divided by minus 2. So when x is equal to 0, we have y is equal to 4 minus 4 into 0 by minus 2. So 4 minus 0 by minus 2, that is minus 2. So when x is equal to 0, we have y is equal to minus 2. Now we can put another value for x, and let's put x is equal to 1. When x is equal to 1, we know that minus 2y is 4 minus 4x and y is 4 minus 4x by minus 2. So when x is equal to 1, we have y is equal to 4 minus 4 into 1 divided by 2. That is 4 minus 4 by 2, that is 0. So when x is equal to 1, we have y is equal to 0. So we got 2 points, that is 0, minus 2 and 1, 0 as the solution. Here we can plot 0, minus 2, that here it is 0 and here it is minus 2. So this is our point 0, minus 2. And when we plot 1, 0, we have 1 here and 0 here. So this is our point 1, 0. Now we want to join these 2 points and find the solution for that particular equation. So this is the line joining these 2 points, and this is the solution set of our equation 2, and this is the solution set of our equation 1. And it is clear that these 2 lines intersect at a point, and the point of intersection is this point, and this particular point is the solution for this pair of linear equations in 2 variables. And we can see that here it is 2 and here it is 2. So this particular point is 2, 2. So the solution of this particular linear pair of linear equations in 2 variables is 2, 2. That is x is equal to 2 and y is equal to 2. So that's this question. Now we can discuss another question. Now the next question is, half the perimeter of a rectangular garden whose length is 4 more than its width is 36 meter. Find the dimension of the garden. We are asked to find the dimensions of a rectangular garden, and 2 conditions are given regarding the rectangular garden, and the conditions are half the perimeter of the rectangular garden is 36 meter and the length of the garden is 4 more than its width, and we are asked to find the dimensions. Both the dimensions, that is length and breadth of the rectangular garden, is unknown to us. So let's represent the length and breadth of the rectangular garden as x and y. That is, x be the length of the garden and y be the breadth of the garden. Now the condition given is that the perimeter is 36 centimeter, not the perimeter, half the perimeter. Half the perimeter of the rectangular garden is 36 meter. We know that the perimeter of a rectangular garden is nothing but the sum of all the sides, that is x plus y plus y. Since the opposite sides of a rectangular are equal, this is y means this is also y, this is x means this is also x. So the perimeter is x plus y plus y, that is 2x plus 2y. So this is the perimeter of the rectangular garden, and it is given that half the perimeter is 36 meter, that is half the perimeter, that is half 2x plus 2y is nothing but 36 meter, which means that 2x plus 2y equals to 36 into 2, and dividing throughout this equation by 2, we will get that x plus y equals to 36. So this is our first equation, which is formed from the first condition, half the perimeter of the rectangular garden is 36 meter. Now the next condition is given, is length is 4 more than its width. We know that this is the length and this is the width. Length, that is x. X is 4 more than its width and the width is y. So 4 more than y is nothing but y plus 4. So from the second condition we got that the length, that is x, is 4 more than the width, that is y plus 4. So x is equal to y plus 4 is the second condition. We can just rearrange the terms and we will get x minus y equals to 4. So these are the 2 conditions which are given in the question, and we have put it into linear equations in 2 variables, and this 1 and 2 together forms a pair of linear equations in 2 variables. And let's write that equations once more, that is x plus y equals to 36, our equation number 1, and x minus y equals to 4, our equation number 2. Solving these 2 equations, we will get the values for x and y, which will be the dimensions of our garden. So we can solve this particular pair of linear equations graphically. For that, let's consider the first equation, that is x plus y equals to 36. We are going to find the solution set of this particular equation, that is corresponding to different x values. We are going to find the y values. Now first of all, for that we want to find the value of y from this equation, that is y is equal to 36 minus x. Now let's put x is equal to 16 first. When x is equal to 16, we have y is equal to 36 minus 16, that is 20. So corresponding to x value 16, we have y equal to 20. Now let's put x is equal to 20. Now we have here 36, y is equal to 36 minus 20, that is 16. So we got y as 16 when x is equal to 20. So we got 2 points and they are 16, 20 and 20, 16. Now let's plot these 2 points in the graph, that is 16, 20. This is our 16, this is our 20, and we are going to plot this particular point very accurately so that we will get the solution also much accurate. So this is our point 16, 20. Now we want another point 20, 16. So this is 20 and this is 16. So we want to plot 20, 16. For that, yes, this is our point 20, 16. So we got 2 points 16, 20 and 20, 16 here, and the line joining these 2 points will be the solution for our equation number 1. Now we want to find the solution for equation number 2. For that, we are going to consider the solution set of equation number 2. For that, we have x minus y equals to 4. From that, we will draw the solution table. First, let's put x is equal to 2. From here, we want to find the y value, that is y is nothing but x minus 4. So when x is equal to 2, we have y is equal to 2 minus 4, that is minus 2. So when x is equal to 2, we have y is equal to minus 2. Now let's put x is equal to 4. Then we have y is equal to x minus 4, that is 4 minus 4, which is 0. So when x is equal to 4, we have y is equal to 0. So we got 2 points, that is 2 minus 2 and 4, 0. Now let's draw these 2 points in the graph. We have 2 minus 2 here. This is our point 2 minus 2. 2 here, minus 2 here. So this is our point 2 minus 2. Now we want to plot 4, 0. We have 4 here, 0 here. So this is our point 4, 0. So we got 2 minus 2 and 4, 0. Joining these 2 points, we will get the solution for this particular equation. Now we are going to join these 2 lines. These 2 points and form a line. Now this is the line joining these 2 points, and we are extending this line to find the point of intersection of the lines representing equations 1 and 2. So this is our line representing equation number 1, and this is the line representing equation number 2. And we can easily find that this particular point, that is 2016, is the point of intersection of these 2 lines. And we know that the point of intersection of these 2 lines is the solution for this particular pair of linear equations in 2 variables. So we got x as 20 and y as 16 as the solution. So x is equal to 20 and y is equal to 16 is the solution for this particular pair of linear equation. That is, our length is x and x is 20 and breadth is y and y is 16. So length is equal to 20 and breadth is equal to 16. So that's the solution for the question asked. Now we can solve another question. Now the next question is given 2x plus 3y minus 8 equals to 0. Write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting, parallel and coincident. We are given with a linear equation in two variables. We want to find another linear equation and thus form a pair such that the geometrical representation become intersecting in the first case, and in another find another equation such that the geometrical representation is parallel, and another representation such that the geometrical representation is coincident. First we have the first equation as 2x plus 3y minus 8 equals to 0. So we know that whenever a pair of linear equations whenever the lines representing the pair of linear equations in two variables are intersecting, we have a1 by a2 not equals to b1 by b2, and in the given equation we have a1 equals to 2 and b1 equals to 3. We want to find another a2 and b2 such that a1 by a2 not equals to b1 by b2. Then we can say that the lines will be always intersecting. Now we want to find an a2 and a b2 such that a1 by a2 is not equals to b1 by b2. Here we have 2 as numerator. So for the ratio a1 by a2 we have 2 as numerator. Let's put denominator as some 3 as my wish. So I have taken a2 as 3. So we got the ratio a1 by a2 as 2 by 3. Now we want to find a b2 such that b1 by b2 should not be equal to a1 by a2. Now for difference, let's take b2 as 5. Therefore, b1 by b2 will become like this. We have b1 as 3 and b2 as 5, and b1 by b2 is 3 by 5. Here a1 by a2 not equals to b1 by b2, and c1 we can choose according to our choice. Sorry, c2 we can choose according to our choice, and let this be 11, 10 or something like that. So we got a2 as 3, b2 as 5 and c2 as 11. So the required linear equation in two variable can be represented as 3x plus 5y plus 11 equals to 0. Considering this equation as our first equation and this as our second equation, these two equations will together form a pair of linear equation in two variables, and surely the lines representing these two linear equations will be intersecting, because a1 by a2 is not equals to b1 by b2. Now the next condition is the lines should be parallel. Here also the given line is 2x plus 3y minus 8 equals to 0. We want to find another line such that the lines will be parallel in the geometrical representation. For that we want to find the condition like this, that is a1 by a2 should be equal to b1 by b2, but that two ratios should not be equals to c1 by c2. Now here we have a1 is equal to 2, b1 equals to 3 and c1 equals to minus 8. We want to find another 3 numbers, that is a2, b2 and c2 such that a1 by a2 equals to b1 by b2 not equals to c1 by c2. We want first of all a1 by a2 equals to b1 by b2. We have a1 here as 2 and a2 we have to find. We have b1 here as 3 and we want to find b2. Now a1 by a2 will look like this, 2 by something, and b1 by b2 will look like this, that is 3 by something. These two ratios should be equal. So I am going to take 2 by 2, which means the ratio will become as 1 by 1 in the simplest form. Now it is necessary for me to make this b1 by b2 equal to a1 by a2. To make this ratio as 1, I have to put the denominator here as 3, that is b2 as 3, and in the simplest form this will become 1 by 1. So here I chose A2 as 2 and B2 as 3. So here A1 by A2 equal to B1 by B2, but we want another condition that should not be equal to C1 by C2. Here we have C1 as minus 8. We should not take C2 as minus 8, because if we take C2 as minus 8, now then C1 by C2 will become 1. So instead of minus 8, we have to take any other number. Let's take 7. So C1 by C2 will become like this, minus 8 by 7, which is not equal to 1 by 1. So we got A1 by A2 equal to B1 by B2, but that is not equal to C1 by C2. So the second equation will look like this, that is 2x plus 3y plus 7 equals to 0. So this is the second equation which takes this pair into parallel lines. Now we will go for the third condition, that is the lines should be coincident. For that we want these three ratios as equal ratios. So we have A1 from this equation as 2 and B1 3 and C1 minus 8. We want to make all the three ratios equal. So we want to find A2, B2 and C2 such that all the ratios A1 by A2, B1 by B2 and C1 by C2 equals to 0. So we can choose A2 as 2, then A1 by A2 will become 2 by 2, that is 1. Now we want to make B1 by B2 and C1 by B2 equal to 1. So in order to that, I want to choose B2 as 3, so that B1 by B2 will become 3 by 3, that is 1. Now in order to make C1 by C2 as 1, I have to take C2 equal to minus 2, minus 8, that is C1 by C2 equal to minus 8 by minus 8 is nothing but 1. So we got A2, B2 and C2. Hence we can find another equation, that is 2x plus 3y minus 8 equals to 0. But look here, this equation and this equation is same. So we want to go for another ratio which remains same for A1 by A2, B1 by B2 and C1 by C2. So rather than taking these ratios to 1, we want to take these ratios to some different number. So let's take we have A1 is equal to 2 and let's take A2 is equal to 4. Then we have A1 by A2 equals to 2 by 4, which is in the simplest form 1 by 2. Now we have B1 is equal to 3. In order to make B1 by B2 1 by 2, I have to we have a fixed numerator for this fraction here, that is B1, that is 3. In order to make this fraction into 1 by 2, I have to put denominator as 6. That is 3 by 6 will only become 1 by 2. So the B2 here I can choose as 6. Now C1 is equal to minus 8. Now C1 by C2 equals to minus 8 by something, which should be equal to 1 by 2. So in order to make this fraction in the simplest form 1 by 2, I have to take minus 16 as my C2. So minus 16 is my C2. Now my negative and negative get cancels. 8 by 16 is nothing but 1 by 2. Now all the three ratios become 1 by 2. So we got A2 equal to 4, B2 equal to 6 and C2 equal to minus 16. So this is our equation, that is 4x plus 6y minus 16 equals to 0. So that's it. This question is a simple question. We will now do another question. Now the next question is, draw the graphs of x minus y plus 1 equals to 0 and 3x plus 2y minus 12 equals to 0. Determine the coordinates of the vertices of the triangle formed by these lines and the x-axis. So first of all, we have to draw the graphs of these two equations. First, let's consider the first equation, that is x minus y plus 1 equals to 0. For the graphical solution, draw the graph, first of all we want the solution set. Let's take x is equal to 0. So when x is equal to 0, we want to find the value of y. So from this equation we want to find the value of y, that is y is equal to x plus 1. So when x is equal to 0, we have y is equal to 0 plus 1, that is 1. So when x is equal to 0, we have y is equal to 1. Now let's take x is equal to minus 1. Now when x is equal to minus 1, we have y is equal to minus 1 plus 1, that is equal to 0. So when x is equal to minus 1, we have y is equal to 0. So we got 2 points and they are 0, 1 and minus 1, 0. Now let's plot these 2 points in this graph, that is 0, x 0, y 1. So this is the point 0, 1. Now we want to plot minus 1, 0. We know that in x-axis this is minus 1 and this is 0. So this is the point of intersection. So this is minus 1, 0. So we got these 2 points and the line joining these 2 points will be the graphical representation of equation number 1. Now let's go for the solution of the graph of second equation, that is 3x plus 2y minus 12 equal to 0. We want the solution set. So corresponding to x values, we want to find the y values. So first let's take x is equal to 4. We want the value of y from this equation, that is 2y is 12 minus 3x. Therefore y is 12 minus 3x divided by 2. Now when x is equal to 4, we have y is equal to 12 minus 3 into 4 by 2, that is 12 minus 12 by 2, that is 0. So when x is equal to 4, we have y is equal to 0. Now let's take x is equal to 0. Now when x is equal to 0, we have y is equal to 12 minus 3x by 2. So y is equal to 12 minus 3 into x is 0 here. So 3 into 0 by 2. Now 12 minus 3 into 0 is 0. So 12 by 2 is 6. So when x is equal to 0, we have y is equal to 6. And that's it. So now we have to plot these 2 points, that is 0, 4 and 4, 0 and 0, 6 in the graph. Now we can plot that 4, 0. This is 4 and this is 0. So this is the point 4, 0. Now we want to plot 0, 6. This is 0 and this is 6. So this is the point 0, 6. So the line joining these 2 points will be the graphical representation of this line. So we can join these 2 lines like this. So this is the line joining these 2 points. This is the line representing our equation number 2 and this is the line representing our equation number 1. Now we can see that if we extend this line like this, here a triangle is formed with the 3 vertices, that is 1, 2 and 3. So these are the 3 vertices of the required triangle and this is the triangle formed. Now we are asked to determine the coordinates of the vertices of the triangle formed by these lines and the x-axis. These are the coordinates and we already know these 2 coordinates. This is minus 1, 0 and this is 4, 0. We have to find this coordinate and we can easily find that this is our x coordinate and this is our y coordinate. So this particular point is 2, 3. So the coordinates of the triangle are, we can write it like this. First coordinate is minus 1, 0. Again, next coordinate is 4, 0. And the third coordinate is 2, 3. So we have drawn the graphs of these two equations like this, and hence we formed the triangle using these two lines and the x-axis. So this is the shaded region is the triangle, and we found the vertices of the triangle. So that's it. This is all for today's class. Wait for the next video.